Hello and welcome to this short lesson on standard form division and multiplication. Before we start, let's just recall what standard form is. Standard form is a number written in the form a times 10 to the power of n, where a is between 1 and 10, including 1 but not including 10, and n is an integer, and an integer is just a whole number. Secondly, we need to make sure that we understand our laws of indices. Our laws of indices say that if we have x to the power of m times x to the power of n, that is equal to x to the power of m plus n. So for example, if we have 10 to the power of 6 times by 10 to the power of 5, our laws of indices for multiplication just says that that is equal to 10 to the power of 6 plus 5, which is equal to 10 to the power of 11. Secondly, for division, our laws of indices say that x to the power of m divided by x to the power of n is equals to x to the power of m take n, which could be written like this as well using the fraction sign. So, for example, if we have 10 to the power of 6 divided by 10 to the power of 5, this is equal to 10 to the power of 6 take 5, which is just equal to 10 to the power of 1, or that can just be written as 10. Okay, so I'm going to go through some examples now of how to actually multiply numbers in standard form. In our first example, we're asked to multiply 4 times 10 squared times 2 times 10 to the power of 3. Both of these numbers are in standard form, as 4 is between 1 and 10, 2 is between 1 and 10, and this 2 and this 3 are integers. The first thing we need to worry about when carrying out this calculation is we need to multiply these numbers at the front together. So in this case, we need to multiply 4 times 2 to get 8. Okay, the second thing we need to worry about is these powers of 10. So the second thing we need to do is multiply 10 to the power of 2 and 10 to the power of 3 together. Using our laws of indices, we know that we just need to add these powers. So 10 to the power of 2 times by 10 to the power of 3 is just going to be 10 to the power of 5, because 2 plus 3 is equal 5. And that's our final answer. It's as easy as that. In our second example, we're asked to calculate 9 times 10 to the power of 6 multiplied by 5 times 10 to the power of 1. Again, the first thing we need to do is look at our numbers at the beginning of each standard form equation. So here we have 9 and here we have 5, and all we're going to do is multiply these numbers together, which gives us 45. The second thing we need to do is address our powers of 10. So we need to multiply 10 to the power of 6 and 10 to the power of 1. And using our laws of indices, this is just 10 to the power of 6 plus 1, which is 7. You might think we're done, but we need to write this final answer in standard form. And 45 is not a number between 1 and 10, so this number is not in standard form. And the way we convert this to standard form is we need to make this number here, 45, 10 times smaller, so it is 4.5, thus a number between 1 and 10. But that means we have to make this times 10 to the power of 7 10 times bigger, which makes it 10 to the power of 8. This may be hard to see at first, but we can think about it another way if you're getting confused. 10 divided by 10 is equals to 1. We know that any number goes into itself one time. So it's safe to write 45 times 10 to the power of 7 from here is actually equal to 45 times by 10 divided by 10 times by 10 to the power of 7. And the reason we can say these are equal is that 10 divided by 10 is just equals to 1, and we're timesing the equation by 1, which does not affect the value of that equation. So what we can do now is split up this fraction of 10 divided by 10 and take the numerator to the right of the equation and take the denominator to the left of the equation, i.e. we get 45 divided by 10 times by 10 to the power of 7 times by 10. This is the exact same thing, we've just split up that fraction in our multiplication. So this gives us 45 divided by 10 is 4.5, and then this is multiplied by 10 to the power of 7 times by 10 to the power of 1, which using our laws of indices is just 10 to the power of 8, which is 7 plus 1, which is another way to get our answer of 4.5 times 10 to the power of 8, converting this 45 times 10 to the power of 7 into standard form. For our third example, we're asked to calculate 5 times 10 to the power of 6 multiplied by 3.4 times 10 to the power of negative 9. Again, the first thing we need to do is address these numbers at the start. We can use a calculator to find out that 5 times 3.4 is just 17. And we need to multiply this by 10 to the power of 6 times by 10 to the power of negative 9. Using our laws of indices, this is just 10 to the power of 6 plus negative 9. I'll just write that in a bracket there, which is just equals to 17 times 10 to the power of negative 3. 6 plus negative 9 is just equals negative 3. Again, this number is not in standard form, as 17 is not a number between 1 and 10. So using a similar method as above, we need to make 17 10 times smaller, which means we need to make 10 to the power of negative 3 10 times bigger. And this gives us an answer of 1.7 times 10 to the negative 2. Okay, so now we're going to talk about the division of numbers in standard form. If you understood how to multiply numbers in standard form, this should come very easy, as it is a very similar process. In our first example, we're asked to calculate 6 times 10 to the power of 9 divided by 2 times 10 to the power of 8. So again, as with multiplication, we just need to address the starting numbers. We just need to address the starting numbers to begin with. So here, we just need to calculate what is 6 divided by 2. Well, that is just 3. Secondly, we need to address these powers of 10. So what is 10 to the power of 9 divided by 10 to the power of 8? Well, if you just remember our laws of indices, we just need to subtract these powers. So we get 10 to the power of 9 take 8, which just gives our final answer as 3 times 10 to the power of 1. And this is in standard form, as 3 is a number between 1 and 10, and our 10 is to the power of an integer, which is a whole number. In our second example, we're asked to calculate what is 1 times 10 to the power of 4 divided by 2 times 10 to the power of 1. Again, we just need to address these starting numbers. So what is 1 divided by 2? Well, that is just 0.5. Now we need to address the powers of 10. So what is 10 to the power of 4 divided by 10 to the power of 1? Well, that is just equal to 10 to the power of 4 take 1. We subtract those powers from our laws of indices. So this would be equal to 0.5 times 10 to the power of 3. But notice, again, this 0.5 is not a number between 1 and 10, so it is not in standard form. So we need to manipulate this equation to make it in standard form. Using a similar method as one of the questions in multiplication, we need to make this number, the 0.5, 10 times bigger to get it between 1 and 10. So subsequently, we need to make this times 10 to the power of 3 10 times smaller. So this is just equals to 5 times 10 to the power of 2. And that's our final answer to this calculation. For our third example, we're asked to calculate 9 times 10 to the power of negative 3 divided by 3 times 10 to the negative 2. Again, we just address these starting numbers. So what is 9 divided by 3? Well, that is just 3. And now we need to address these powers of 10. So what is 10 to the power of negative 3 divided by 10 to the power of negative 2? Well, we'll just use our laws of indices and do a subtraction. So this is equals to 10 to the power of negative 3 take negative 2, which gives our final answer as 3 times 10, and negative 3 take negative 2 is just the same as negative 3 plus negative 2. Subtracting a negative is the same as addition. So we get our final answer as 3 times 10 to the negative 1. If you have any questions, feel free to email me or drop a comment. Thank you for listening.